You walk into a gym, um, it really doesn't matter if it's some high-end health club in London or a dusty garage gym in Ohio, and you are guaranteed to see the exact same ritual.
Oh yeah, the foam rolling area.
Right. It's always crowded. You've got people down on the mats, grimacing, completely contorting themselves over these dense black cylinders. I mean, it's basically become as fundamental to modern fitness culture as, a post-workout protein shake.
It really has. It's almost this universal signifier of taking your recovery seriously. There's this mindset of, if you aren't rolling, are you even really training?
Exactly.
Yeah.
But here's the problem I keep running into, and frankly, I've been entirely guilty of this for years. We treat the foam roller like a rolling pin, and our muscles like bread dough.
Just mashing it out.
Yeah, we just match. We assume the magic is entirely in the pressure, like the harder it hurts, the better it works. But we almost never talk about the variable that might actually matter the most.
The velocity.
The speed. Does it actually matter if I'm rolling like a slow-moving steamroller or, zipping back and forth like a Formula One car? And today, in this deep dive, we are putting that exact question under the microscope.
We have a really fascinating paper for this one.
We do. It's titled The Effects of Foam Rolling at Different Speeds on Mechanical Properties of Quadriceps Femoris.
Yeah, and for some context, this is a 2024 study. It was published in the Journal of Sports Science and Medicine, specifically volume 23.
And the research team behind this.
It was led by Atilla Çağatay Sezik, along with a team including Özgün Uysal, Tuzun Fırat, Irem Düzgün, and Volga Tunay. They essentially looked at the fitness landscape and decided that, roll until it feels good just wasn't a rigorous enough metric, especially for elite performance.
Which brings us to our mission for today's deep dives.
Yeah.
We aren't just looking at some generic concept of flexibility here. We are drilling down into three very specific, highly measurable mechanical properties.
Yeah.
Muscle tone, stiffness, and elasticity.
Right, and seeing how the speed of the roller directly manipulates those inputs.
And doing so in a very specific, high-level group of people.
Yeah.
So let's set the stage. Who exactly are we putting under the microscope here?
The participants were 18 male professional basketball players. These are active athletes playing in the Turkish Basketball Super League.
Okay, so these are guys who literally live and die by their legs.
Exclusively. And this is a really critical distinction to make early on. We aren't looking at the average office worker or even the weekend warrior here. We are looking at physiology that is meticulously tuned for high performance.
Because their baseline tissue is going to be different.
Exactly. The muscle density, the fascial thickness, the resting tone of a pro basketball player, these are dense, powerful, hyper-facilitated muscles. They are under constant, explosive load every single day.
And I'm assuming these guys weren't strangers to the foam roller.
Not at all. They all had at least a year of consistent experience with it. They knew the drill, which honestly makes the behavioral results we'll get to later even more fascinating.
Oh, absolutely. But before we get to the actual protocol, we really need to define our terms. I feel like in the fitness world, we throw around words like tight, stiff, and toned completely interchangeably.
We do, and it's a huge problem. Conflating those terms is exactly where a lot of our recovery strategies go completely off the rails.
But in a lab setting, those words mean very, very different things, especially when you're using the specific device they used in this study.
Right, the Myoton PRO. It's this really clever, non-invasive device. It looks a bit like a heavily modified digital thermometer.
And how does it work?
You place the probe against the skin, and it delivers this tiny, precise mechanical impulse to the tissue. Then it just measures how the muscle and fascia oscillate, how they vibrate in response to that tap.
Okay, so let's break down the three variables it measures. The first one is muscle tone. Now, to the average person listening, tone usually implies, how cut someone looks in the mirror.
Yeah, the aesthetic definition. But in biomechanics, tone is the passive tension in a muscle when it is completely at rest. It's measured in hertz.
The frequency.
Exactly. The best way to think about this is to imagine your muscle like a guitar string. Even when you aren't actively playing a note, that string has a baseline level of tension on the neck of the guitar.
Okay, I like that. So it's the resting readiness.
Precisely. If you pluck a very tight string, it vibrates at a high frequency. That's high tone. If the string is loose, it's a low frequency, so low tone.
Meaning high tone doesn't mean you're flexing.
No, high tone means the muscle is in a constant state of neurological readiness, or maybe even overactivation, even when you're just sitting there.
Got it. High tone isn't strong, it's tense. Okay, variable number 2.
Elasticity. This one is fairly intuitive for most people. It's the ability of the tissue to recover its original shape after it's been deformed.
Like a rubber band.
Exactly. If I press my thumb deep into your quad and let go, how quickly and efficiently does the tissue bounce back to normal? They calculate this using something called logarithmic decrement.
And the third variable, which I really think is the one people confuse with tone the most, stiffness.
Stiffness is strictly mechanical. It's measured in newtons per meter, and it represents the tissue's resistance to an external force.
So back to the guitar analogy.
Right. If tone is about the neurological tuning of the string, how tightly the peg is, wound stiffness is about the material properties of the string itself.
Is the string made of rigid steel or flexible nylon?
Exactly. A stiff muscle literally requires more physical, mechanical force to bend or deform it.
That is such a crucial distinction for anyone listening. Tone is neurological tension. Stiffness is structural resistance.
You can have high tone but low stiffness, or vice versa. They do often correlate, but knowing which one you are actually trying to change should dictate your entire recovery strategy.
All right, so we have our 18 pro ballers. We have our Myoton PRO device. What did the researchers actually have these guys do?
They use a crossover design. That means every single athlete did every variation of the experiment in a randomized order, and they separated each session by a week of rest to ensure there were no carryover effects.
Very rigorous. And what was the tool?
A Black Roll Pro. It's a standard, very high-density, hard, cylindrical foam roller.
And the physical position they were in?
Prone, so face down on the mat. They were rolling the dominant quadriceps. The path was from the hip bone, the anterior superior iliac spine, straight down the side to the top of the kneecap.
Just the standard quad sweep.
But here is the kicker. They did it with crossed legs.
Oh, wow. The three-point contact.
Yeah. 2 forearms on the ground, the dominant leg on the roller, and the non-dominant leg stacked directly on top of the rolling leg.
Ouch. I mean, that significantly amplifies the pressure compared to just rolling both legs side by side.
It's intense, but they had to do it that way. To ensure enough mechanical load was actually penetrating those dense athletic muscles, they needed that extra weight. If you just kind of float lightly on the roller, you aren't stimulating the deep receptors at all.
Okay, this brings us to the absolute core of today's deep dive. The speeds. Because they didn't just say, hey, roll fast or hey, roll slow.
No, they defined it meticulously by beats per minute using a metronome.
Okay, so condition 1.
The first condition was SO low. This was set at 15 beats per minute.
Let's help everyone visualize that. The quad is a big, long muscle. What does 15 beats per minute actually look like in motion?
At 15 BPM, you are taking 4 full seconds to travel one way from the hip to the knee. 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi.
That is excruciatingly slow.
It feels incredibly tedious when you're actually doing it. It requires serious patience and a lot of core control just to move that slowly.
Right. And then the fast condition.
30 beats per minute, so exactly twice as fast, 2 seconds per stroke. Zip down, zip up.
Which honestly feels a lot more like the standard gym rhythm you see every day. You hop on, roll it out quickly, hop off.
It does. But then the researchers added a third condition, which is honestly my favorite part of the entire study design. They called it self.
The intuitive mode?
Yeah. They simply told the athletes, roll at the speed you personally think is most effective. No metronome, no counting. Just do what you've been doing for your whole career.
This is the ultimate reality check. So, before we even touch the physiological changes, let's look at the human behavior here. We have slow at 15, fast at 30. What did the pros choose when left entirely to their own devices?
They chose speed. High speed. The average self-selected rolling cadence was 33 beats per minute.
Wait, really? So they instinctively rolled even faster than the experimental fast protocol?
They did. The fast protocol was 2 seconds per stroke, and the athletes were practically sprinting up and down their quads.
That says so much about human nature, doesn't it? We just inherently equate intensity and speed with efficacy. Like, if I do this faster, not only do I get it over with sooner, but it probably works better.
Or it's simply sensation-seeking. Fast rolling generates a lot of friction, a lot of heat, and maybe more immediate sensory feedback. It genuinely feels like you're doing work.
Right, but we so often confuse the sensation of effort with the actual physiological mechanism of change. So the million-dollar question, was their intuition right? Did that supersonic 33 beat per minute rolling produce the best mechanical changes in the muscle?
In a word, no.
All right, let's break down the data. Let's start with muscle tone, that guitar string tension we talked about.
This was easily the most significant finding. They measured tone right before rolling and then 5 minutes after, and they found that both the fast group and the slow group saw a significant decrease in muscle tone.
Okay, so the good news is rolling does work to lower resting tension, regardless of the speed.
It does.
Uh-huh.
However, and this is the big takeaway, when they ran the post-hoc analysis to compare the specific groups against each other, the SO-low application resulted in a significantly greater reduction in tone compared to the self-application.
Wow. Let that sink in for a second. The athletes naturally chose to roll at 33 beats per minute, but the 15 beat per minute speed, which is less than half the speed they intuitively chose, was statistically superior at actually relaxing the muscle.
Their own intuition literally led them to the least effective strategy for tone reduction. By rushing through it, they were totally shortchanging their own neurological response.
Why, though? What is the actual mechanism happening under the skin here? Why does a slow 4-second roll make the muscle relax so much more than a fast one?
The authors point straight to the mechanoreceptors. Your fascia and your muscle tissues are absolutely packed with these tiny sensors. Specifically, we're talking about Ruffini endings and Pacinian corpuscles.
These are the biological sensors that tell the brain what's physically happening to the tissue.
Correct. Ruffini endings, in particular, are what we call slow-adapting receptors. They respond best to sustained, deep pressure and tangential forces.
Tangential meaning?
Like a shearing force. The exact kind of dragging, heavy force you get from a very slow, deliberate pass with a hard roller.
So if you go too fast, you just aren't giving those specific receptors enough time to wake up and register the pressure.
Essentially, yes, you're just skimming right over them. But when you move slowly, using that agonizing 4-second count, you deeply stimulate those Ruffini endings.
Yeah.
And when they get stimulated, they send a powerful signal up to the central nervous system that actually inhibits sympathetic nervous system activity.
It's literally sending a stand-down order to the muscle.
Exactly. It lowers the global motor neuron excitability. It's the body's way of telling the muscle, hey, we are safe, the pressure is consistent and non-threatening, you can drop the baseline tension now.
And the fast rolling.
Fast rolling tends to stimulate different receptors, like the Pacinian corpuscles, which are tuned for vibration and rapid transient changes.
Yeah.
But they just don't have that same powerful, systemic relaxing effect on the resting tone.
I love that. So slow rolling is an actual conversation with the nervous system. Fast rolling is just noise.
That's a fantastic way to put it.
All right, so that heavily covers tone. What about the other two variables, stiffness and elasticity? I would assume that if the tone dropped so significantly, the stiffness must have dropped too, right? If the guitar string is looser, the material itself should feel softer.
You would certainly think so. But this is the second major surprise of the study. There were absolutely no significant changes in stiffness or elasticity in any of the groups.
Wait, zero.
Statistically null. It didn't matter if they went slow, fast, or used their self-selected speed. The mechanical stiffness, the physical resistance to deformation remained exactly the same across the board.
I find that so hard to wrap my head around. Because when I foam roll, I feel physically looser afterwards. So if my tone dropped, shouldn't my stiffness be lower too?
Not necessarily, and this brings us right back to that vital distinction between neurological input and material properties. Tone is the electricity running through the house. Stiffness is the wooden framing of the house itself.
Okay, unpack that framing analogy a bit more.
Changing the actual physical architecture of dense fascial tissue takes a lot more than 2 minutes of rolling. The authors discuss this really interesting concept called thixotropy.
Thixotropy, that is a great word.
It's a great concept. It describes how certain fluids become less viscous, more liquid, when they are agitated or stressed. The prevailing theory in foam rolling is that the pressure should turn the ground substance of the fascia from a thick gel into more of a liquid state.
Kind of like vigorously stirring a can of thick paint until it thins out.
Exactly. But here's the catch. While that thixotropic effect might happen superficially or temporarily, the structural stiffness of the deep fascia and muscle fibers in an elite basketball player is incredibly resilient.
Because they've spent years building that armor.
Right. The study suggests that the duration of the rolling protocol, they did 2 sets of 15 reps, which comes out to roughly 60 to 120 seconds of total work. It simply wasn't a large enough dose to induce what we call a creep response.
And a creep response is the actual physical lengthening of the tissue under sustained load.
Correct. To truly change the physical stiffness of a professional athlete's quad, to make the material structurally softer, you might need 5, 10, maybe 20 solid minutes of sustained heavy pressure. or months of consistent, targeted work. You simply can't remodel the car's chassis in 2 minutes, even if you can successfully tune the engine.
That is such a vital takeaway for anyone listening. In a standard foam rolling session, we are changing the software, the tone, not the hardware, the stiffness.
Precisely. And for the athlete, that software change, that drop in neurological tension, is almost always what feels like relief.
I want to circle back to the physical mechanism of slow rolling for a second, because the paper mentions another really interesting theory involving something called hyaluronan.
Ah, yes, the gliding theory. Hyaluronan is essentially the biological lubricant between your fascial layers. It's what allows your quad muscles to smoothly slide past your hamstrings and your skin to slide over your underlying muscle.
The oil in the engine.
Exactly. When this lubricant gets sticky or densified due to overuse or lack of movement, you feel incredibly stiff. Now, rapid fast rolling creates friction and heat, which certainly can reduce that viscosity a bit.
Right.
But the study suggests that slow rolling might have a highly unique mechanical benefit. It mechanically separates the fascial layers.
It actually opens up the space.
That's the theory. The slow, heavy shear force acts almost like a squeegee. It pushes the old sticky fluid out of the way and allows the tissue layers to gap slightly. And that gapping invites fresh, healthy hydration back into the area.
Whereas if you roll too fast...
If you roll too fast, you might just be vigorously compressing the layers together without ever generating that deep shearing, gapping effect.
So slow rolling creates space, while fast rolling really just creates friction.
And if you care about long-term tissue health and maintaining smooth gliding surfaces, creating that space is likely far more valuable.
This perfectly leads us to the practical application portion of this deep dive, the so what of it all. We have this clear data. Slow is undeniably better for lowering tone. Stiffness doesn't really change acutely no matter what you do. And athletes naturally, intuitively choose to go fast. So how do we actually apply this knowledge?
Well, context is absolutely everything here, because the most provocative takeaway from the authors isn't just a recommendation, it's actually a warning.
A warning about what, specifically?
About when you choose to roll. We just established that slow rolling significantly drops your muscle tone, right?
Right. It tells the nervous system to stand down.
So if you are a professional basketball player and you are about to step onto the court for tip-off, do you actually want low muscle tone?
I would assume. Definitely no. You want to be explosive and ready.
Exactly. Muscle tone provides the essential pre-tension required for rapid reaction times. It's the spring being tightly coiled. If you use a slow 15 beat per minute rolling protocol right before a game, you are actively telling your nervous system to relax.
You're literally sedating your own legs.
You are. And you risk a delayed reaction time. In an explosive sport like basketball, a millisecond delay in a muscle firing can mean a missed rebound, or much worse, a severe injury, because the stabilizing muscles just didn't fire fast enough to protect a joint.
Oh, wow. So the fact that the athletes instinctively chose to roll fast, that 33 beats per minute, might have actually been a happy physiological accident.
It's highly possible. Their cell-selected speed was objectively less effective at lowering tone. Therefore, it was likely much safer to use as a pregame warm-up simply because it didn't sedate the muscle as deeply.
That is the ultimate speed paradox. The worst technique for deep recovery going fast might actually be the best technique for a warm-up, simply because it fails to relax you.
It's a classic case of better is not always better. You have to clearly define what your biological goal is in that exact moment.
So let's categorize this clearly for the listener.
Here.
Because we have people listening who might be runners, powerlifters, or just everyday people trying to fix a stiff lower back.
Sure, if your immediate goal is warm-up and preparation for activity, you probably shouldn't be foam rolling for tone reduction at all. Or, if you do enjoy it, keep the speed fast and the pressure somewhat superficial. You want to generate some heat and blood flow without deeply inhibiting the nervous system.
Keep the spring coiled, and if the goal is recovery, say post-game or post-workout.
That is the exact moment you need to fight your own intuition. After a hard session, your baseline tone is sky high. Your system is hyper-facilitated. That is when you need to get down on the floor, literally look at the clock, and force yourself to do the boring, excruciatingly slow 15 beat per minute roll.
That's when you finally need to hack those Ruffini endings.
Correct. You have to consciously override that let's get this over with impulse if you want to get the actual physiological benefit of neurological relaxation.
It really challenges this whole modern idea of intuitive training. We hear that buzzword constantly, just listen to your body. But in this specific case, the body is screaming to go fast, and the hard science is definitively saying to slow down.
Intuition is very often just habit disguised as wisdom. Or, frankly, it's just the path of least resistance. Slow rolling is uncomfortable, it's tedious, it's boring. Our intuition naturally steers us away from it. But real recovery sometimes requires deliberate discipline, not just chasing a state of flow.
Before we wrap this up, I do want to make sure we manage expectations here. We are strictly talking about acute, immediate effects in this study, right?
Yes, absolutely. These myoton measurements were taken exactly 5 minutes after the rolling protocol ended. We don't know for sure if that profound tone reduction lasted for 30 minutes or 3 hours. And we certainly saw that the physical stiffness didn't change at all in that short window.
So if you're someone with chronically stiff, fibrotic quads, slowly rolling them one time isn't going to magically fix the tissue architecture.
No, it won't. Changing stiffness requires chronic, long-term load management, probably heavy eccentric strength training, and perhaps much longer duration soft tissue sessions to finally deal with that thixotropic response we talked about.
Yeah.
You simply can't undo 5 years of accumulated attention in 60 seconds on a roller.
But for managing that day-to-day neurological tension, for dialing down the nervous system after a hard day,
For that, speed is the exact dial you need to be turning.
I love that visualization. The foam roller isn't just a dumb piece of foam. It's a device with settings, and you entirely control the setting with your velocity.
Exactly right.
If you want to dive deeper into the actual charts and see the specific data points, I highly recommend pulling up the full paper. Again, it's the effects of foam rolling at different speeds on mechanical properties of Quadriceps femoris by Sezik and colleagues, published in the Journal of Sports Science and Medicine.
The data visualization on the tone drop is really worth looking at. It makes the performance gap between the intuitive self-selected speed and the controlled slow speed look very, very stark.
And as always, if you appreciate this level of nuance, where we don't just sit here and say rolling is good, but we actually ask how and why, make sure you are following the channel. Turn on your notifications. We have some fantastic deep dives coming up on recovery nutrition and the actual hard science of sleep hygiene that are going to align perfectly with what we talked about today.
I'm really looking forward to digging into those.
Here is the final thought I want to leave you with today. We just found out that our completely natural instinct to roll fast and hard is actually totally inefficient for our primary goal of relaxation. It really makes me wonder, what other intuitive recovery habits do we all have that might be completely backwards?
Right. Are we icing injuries when we actually should be heating them? Are we aggressively stretching into pain when we really should just be breathing into a supported position?
Just because an intervention feels like hard work doesn't actually mean it's working. Something for you to mull over the next time you're painfully counting 1 Mississippi on the gym floor. Thanks for listening.
Take care, everyone.